what do we have here? I have this mobile phone received from another shop, so this phone is not charging, and if you look right here you will see that we have some burns in the charging plug, around the charging plug, right? So I plugged the phone and charged to see if the phone is going to charge. As you can see, there is no charge, so maybe high voltage burned, like you see the power capacitor right there. So I have to set my multimeter to DC range to test if there is any charging voltage around in the battery connector. I tested and there is no charging voltage, which means that anything that happens to the phone is serious. The battery connector doesn't have a voltage, you understand. So I had to take a good look at the mobile PCB. As you can see, we have serious burns, and the technician replaced that capacitor right there. So I had to clean everything to make sure that I'm seeing everything clearly. You can see me cleaning the PCB right here. Okay, so you take a good look right here, you will see we had serious burns there. And okay, so I had to set my multimeter to buzzer mode because I had to test to see if all the diode readings there are okay. And that's a positive of the Vbus, not giving a reading. That's a negative, it's beeping. That's a positive. It was supposed to be giving a reading, yeah, you understand. So there is no reading right there. I know that there is an open circuit, you understand. I know that there is an open circuit right there. I test the jumper points right there, and they seem to be okay. So that's a DM and a DP in which I'm testing. So I found out that I have 1 point right there. So I also turned to the other side and tested the Vbus straight at the at the charging connector. As you can see, that's the Vbus line, and there was no reading, which means that there is an open circuit between the Vbus and the charging IC. It was supposed to be given a reading, right? So from here I know that the burns caused an open circuit. So I connected my charger again and make sure that I can find the 5 volt in the jumper point, so that I will know that the problem is from the jumper point to the charging IC, you understand. So as you can see, I tested and I saw 5 volts. I don't know if you are seeing what I'm explaining right here. Let me turn this. Okay, there was 5 volt right there, and there was no 5 volt in this diode. There was no 5 volt in that diode, and the other point right here did not have a voltage normally, but that had 5 volt. There was 5 volt, no 5 volt here. Oh wow, that that wasn't even sold that well. So I just had to push this, and it went off. So which means that it was not even connected. Which that cannot be the problem. You need to keep that in mind. That capacitor is connected. Sorry, the diode is connected in parallel, which means that wasn't a big problem. As you can see, this is the jumper point, very clear. Right here we have 5 volt, but we doesn't have 5 volt. Like you can see right here. The other side of the 5 volt, which is the Vbus, was supposed to be connected right there. As you can see, we have serious burns right here. So I had to make sure everything is clean. So skip the first layer and get to the second layer of the PCB because the first layer, which is was burned right here. You can see the first layer was burned, and looking right there, I can already see that we have open circuit right there. So you can see that we have 3 separated parts. The one that looks like a hole is the one that is taking the Vbus right into the PCB to the charging IC, and we have this other small one right here which is broken, which was supposed to be connected to this other bigger part. So I had to drill down a little bit. And as you can see, I was looking at the inner layers of the PCB because I had to drill down to test. You understand? Because after testing with my multimeter, as you saw earlier, I tested with my multimeter, and only the pin that I'm drilling right there was beeping, and the bigger one right here was beeping, which means that there is a short. The Vbus is shorting. As you can see, there's a short right there. There's a short. All these areas are shorting, which means that the layers are all shorting. So I had to drill down again had to drill it down again and yeah, see how everything is right here, because this area had serious burns. So I had to make sure that the problem is coming from this area, because it might be from the charging section. Maybe the high voltage caused the shortage in the charging section. I just had to drill to make sure that everything is okay right here. So I had to make sure that every pin is separated right here, as you can see. Okay, you can see right there. Okay, so I tested again and everything was beeping except this small part right here. That small part is not beeping, which means that there is an open circuit and also a short circuit. So I had to find where the charging IC is to test everything in the charging section to make sure where I am going to start troubleshooting the fault. So I had to cut the shield up rather than hitting it up, for some safety reasons, not to overheat the CPU, cause something circuit and all that stuff. So I had to do this. I first trimmed this other side and the charging IC was not there, so I had to do this other side again because I noticed that it was in this section here. Okay. Okay, so I cleaned everything. Here is the charging IC. As a charging IC, I tested that capacitor and there is a beep in both sides, but it's not a 0 ohm reading. So it shows that there is the shorting it's not a full short. You understand? It's a half short because the other side has I think it's about 90, was it 30 something ohm, right? So I don't know, I did not record the multimeter, so I tested. I know that the line is not shorting with the GND, that's why it's not a full short. So I know that the line is shorting right here. So somewhere with maybe some other pins in the inner layer of the PCB. So I had to drill down again. I just had to make sure that the problem is coming from here. You understand? Before I can know what to do. So I drilled down the PCB again to see if I could see a short. So I did not go deep down in the PCB yet, just drilling a little bit, testing if everything is still connected. Everything was still connected, right? So what I had to do, I had to inject a voltage because there was no full shorting right here, right? So I noticed that's supposed to be a positive. I inject a voltage right there. I inject 5 volt. Yeah, 5 volt was okay, right? So I noticed that this diode right here is also burnt, but that cannot be the cost of the beeping in the Vbus section. You understand? So I did not take a look right there. I already knew that I had to focus somewhere else before checking that later. So I came back right here and I had to jumper a cable from here. So as you can see, you have the charging IC, we have that power capacitor right there which received the Vbus directly. So I had to solder a cable. So just check on what I'm going to do right here. Check out what I'm going to do. The reason why I'm doing this, I want to know the exact section in the mobile PCB that is causing the full short. Either it's a component or a particular section in the PCB layer. I can detect that by doing this jumper. What was I doing? Okay, my soldering iron tip was really bad right here. I had to change it. So I soldered the cable, then connect to the 5 volt and take a look at what will happen right here. Take a look. Okay, you see that smoke? I don't know if you're seeing that clearly, but that's smoke, which means that the shorting is coming right here in this burned area, but in the inner layer of the PCB. Okay, but I did not solve the problem because I chatted with the customer. I told the technician that I have to do this for this amount, and he chatted with the customer, but the customer was not ready to fix the device. So that was it. But I could have just drilled down again carefully and solved the problem, solved the open circuit, but the customer was not ready to fix it. You understand?